So as I said, I've given this presentation a few times, but this is the first time that I'm getting a full 45 minutes. So I'm happy because the last few times I've given this, it's been a 30-minute slot. And 30 minutes is not a very good amount of time for introducing you to all of Kubernetes and Drupal and things like that. There was also a presentation yesterday which barely fit into that 45 minutes but had a wealth of knowledge. This one does not have a wealth of knowledge, but hopefully you at least get something from it. But the presentation is everything I know about Kubernetes I learned from a cluster of Raspberry Pis. And this was actually true for about a week or so, and then I stopped using the Pis because it takes like a week or so to get them running Kubernetes, and then it takes another week to get them fixed once you break it. So I started using other faster computers, but I still did a lot of stuff on the Raspberry Pis. And if you came to this presentation thinking that this morning you'd have a nice dish of Raspberry Pi, that is not the case, unfortunately. I don't have any kind of breakfast food for you whatsoever, but I do see some food heating up out there, I guess, for lunchtime in a couple hours. I don't think there will be Raspberry Pi there either. So sorry for showing you that wonderful scrumptious picture. But how many people here in this room have a Raspberry Pi? Okay, how many people in this room are using a Raspberry Pi? How many people in this room have the Raspberry Pi, or have a Raspberry Pi sitting in a drawer somewhere, in a box or something? So there's a question around, like, we're all tech people, and we love tech, and the Raspberry Pi came along, and it was this $35 computer that was like a full computer, but a little credit card size thing. And it's just so cool, and it's only 35 bucks, so everybody had to have one. And then you got one, and you're like, what do I do with this thing? Because it's not as fast as my normal computer. You find out that you actually have a mess of cables plugged into it to do anything with it, and then you start buying cases for it, and you might have more accessories for your Raspberry Pi than you actually have uses for the Raspberry Pi. So a question that I had was, what can I do with the Raspberry Pi? I had a few different things that I did with mine. I built a temperature monitoring system for my house because I noticed that one room, the room that my kids were in, which, if you have kids, you want to protect them. That room was getting very cold at night in the winter, and I wanted to see just how cold it was, and if it was hitting that threshold of like where SIDS risk increases and things. And much to my alarm, it actually was getting down to like 65, 66 degrees. So with the temperature monitoring stations that I set up in the room, I found out that our HVAC system wasn't actually adequate for that room's heating in the winter. So I bought a wall heater that's safe for kids and things, kept measuring the temperatures, and saw that I could keep the temperature around 70, 71 degrees, which is much more safe. So there's some practical things you can do with Raspberry Pis that would be harder, if not impossible, depending on your programming skills, to do with other kinds of devices like Arduinos and things. That's one thing. Some people host websites on their Pis. Some people use their Pis for educational purposes, to teach kids how to code, things like that. Some people use them as media centers. There's lots of different things you can do with the Raspberry Pi. But I am a little bit crazier than that. And I thought, there's this thing called Kubernetes. It's from Google. It runs like all of their planets' data center hosting stuff and things like that. How well does that run on a little $35 credit card sized computer with a little old mobile phone processor? And then I was even crazier because I'm a Drupalist as well. And I thought Drupal 8 is like this giant enterprise grade CMS that we use at Acquia and elsewhere to build these huge media experiences, or as we call them now, ambitious digital experiences, or whatever they're called. So how well does that run on top of Kubernetes, on top of these little Raspberry Pis? And I got into it, but when I started looking into it, I was like, Kubernetes itself, there's a lot of things about it that made it kind of alarming when you try to run it on a small computer. And I needed to find out a little bit more about what Kubernetes is. And some of you in this room may also not know. Who here was not at Tessa's presentation yesterday? So a few people were not, and so you don't know everything about Kubernetes yet. It's okay. In 45 minutes, you can learn everything you need to know about Kubernetes by looking at her presentation, which is recorded and is already online. But if you didn't go to that, or even if you went to that and you forgot everything because you were starting to glaze over once you heard the 15th new term about Kubernetes, here's a very quick overview of what it does. So for a Drupal website, or for any kind of application that we run nowadays, there's lots of different services and apps that we need to run. So for a big Drupal site, you might have Drupal with like web containers or web servers, MySQL with a database, and you might have a master and a slave or some other setup for that. You might have like a chatbot that's running in Node.js that integrates with your Drupal site. You might have a Solr server or Elasticsearch. You might have cron running in the background. You want to have logging so that you can get your logs centralized. There's a good presentation on that with CloudWatch yesterday. You might have Redis for caching or memcache. So you have all these different things that you need to run. And traditionally, you'd put them all on a big server, and you'd have maybe some way of managing that, or you'd split them up into many servers. But Kubernetes came along because we're all running all these different applications nowadays, and everybody's like this. You know, except for the very small sites, everybody has lots of different things that they need to run. So Kubernetes, at a very basic level, we're like training wheels in this presentation because, like I said, this was designed for 30 minutes, not for about 6 hours. So at a very basic level, Kubernetes takes all the things that you need to run, your workloads or your applications, and it schedules them onto different servers, onto different setups using the things that you tell it to do. Like if you want it to be able to scale and things like that, you can tell Kubernetes. And then it also monitors everything and makes sure they're running. So if a server goes down, it brings it back. It brings those things that were running on it back up somewhere else. If one of your services is unreachable, it starts trying to figure out ways to get it to be reachable again. So, as I said yesterday, there was a very good presentation that goes very deep into the details on running Drupal and Kubernetes. And unfortunately, in this presentation, because I'm talking about the training wheels type things, I don't have the time to get so deep into that, but I'll get as deep as I can, since I have a few extra minutes. So you're telling me, so I'm telling you that I'm building this thing on Raspberry Pis. I have 4 Raspberry Pis up here, and I have a Power Ethernet hub and all these lights and things. And I'm going to be running this thing in Kubernetes. I'm going to be using Drupal 8. And you might be wondering, like, what is the site that you're going to be running? Is it like a large community website? Is it some ambitious digital experience for a large company? But no, it's actually a static HTML website, basically. But it's running in Drupal 8. So the point of this is more to demonstrate. And you might be thinking that this is kind of crazy. And you might also be thinking that it's something like this picture, which is... in the real world, a lot of people end up doing something like this, which I don't recommend for production things. If you don't need Kubernetes, you probably shouldn't try using Kubernetes. There's a lot of great use cases for it, but it's not for everything. My personal website is not running on Kubernetes, but if you can't see this picture that well, it's a large flatbed truck, an 18-wheeler, and there's like a brick on top of it being transported somewhere. And that's kind of what this is, hosting a static HTML website, in essence, a static HTML website on a cluster of 4 Raspberry Pis. And for me, this is a hobby, and it doesn't really have to make sense what I'm doing. It's more for the fun and the passion. It was also something where I've learned as I've gone. I've been running this cluster for 5 years now, and through that time, I started with the Raspberry Pi Model 2, I think, in 2014, and I went on to, I even tried doing a Raspberry Pi Zero cluster. And how many people here have seen the Raspberry Pi Zero W, or is it Zero? Those computers are even smaller. They're the size of like a stick of bubblegum. They're super tiny. But there's a couple problems with that. I thought it would be super cool to come into this presentation with a completely wireless setup with a little USB battery pack in my pocket, and then kind of pull it out and show you that it's all running all this Kubernetes and stuff. But there's a few problems. Not only does it not have enough RAM to run Kubernetes, that model only has 512 megs. It could run some other flavors of Kubernetes, but it's also about 12 times slower, so installing things on it takes, instead of like 2 weeks, like 2 months. And I'm only exaggerating a little bit. One time I started the PHP build, and it took about 2 days for it to finish. So I don't really recommend that. And it also gets extremely hot, so I didn't want to come in with a burn on my leg into this presentation. So I kind of scrapped that idea. I did get it working without Kubernetes, but it was not. It wasn't very impressive, and the numbers were very bad. It served like 2 requests per second or something, which might sound like an okay amount, but the other cluster serves like hundreds. So not a great idea, but it was cool to do. Not cool in practice as I thought. So kind of burned a little time on that. But I sold those off for like $1 a piece to some other people, so I might have made some other hobbyists happy. This is my new cluster, and you might be wondering, if you look back at this picture, there were 5, and at one time you even had 6 Pis. Why did I go down to 4 Raspberry Pis? And the answer for that is pretty simple. You can see all these pictures through the years. I've had all these different Pis. I sink some money into this project, and like I said, it's just for fun and hobby. The 4-port power over Ethernet adapter costs like $50. The 8-port one costs like $120. So it's just a cost decision. And just to let you know, all of the parts and everything that I've used for this, I have 2 flavors of it. I have the one without power over Ethernet and the one with power over Ethernet. That just lets me save carrying an extra power supply and adapters and all that kind of stuff. The 2 flavors of it are both, all the parts lists are online at pidramble.com. There's a link to it at the end of the presentation. And you can build your own if you want. All the source code for this is also available there. And the first thing you encounter, though, is you have these Raspberry Pis. You might have bought all the parts. Somebody even mentioned they have all the parts in their Amazon cart. So once they arrive to your house, how do you get Kubernetes and how do you get Drupal onto the cluster? My answer for that is partly because it's kind of my golden hammer for infrastructure stuff, but also because it's a really good tool for the job, is Ansible. And I call Ansible configuration management for humans. It's also, in addition to configuration management, it does orchestration, it does network management and things like that. It even manages Windows pretty well nowadays. It's a very powerful tool for any kind of automation needs that you have. And does anyone know how, I have some stickers. I actually printed some more since DrupalCon. At DrupalCon there were only 10 of these in existence. Now there's like 40 of them. So I have some of these. Who can answer, how do you get that little cow to appear in your terminal? Yeah. Yes, you can have this. So now you are the owner of one of 40, 45, I don't remember how many exactly there are now, but there's an official Pi Dramble sticker. And the difference between this and the Raspberry Pi logo is, instead of little round circles, these are little blue Drupal. Very fancy. So yeah, Ansible has a little inside joke, is if you have Cowsay installed on your computer, it will put all the output inside of little Cowsay quotes. So you'll see a bunch of little cows going down your terminal as it does your automation. You can disable that, of course, and I have, because it takes up a lot of vertical space. But it's kind of funny the first time. So let's give a little demo. I want to show, first of all, how Ansible itself can manage infrastructure. In this case, it's technically bare metal. You can even see the metal parts on this cluster. It's a bare metal set of servers, and Kubernetes runs great on bare metal. It runs great in cloud environments. There are managed Kubernetes environments. And depending on your needs, one of these different things might be the best fit if you need Kubernetes in your organization. So let me go in here. I'm going to show how Ansible can manage the individual nodes themselves first, and then I'll get into Kubernetes after that. So first of all, I'm going to use the Ansible command line. These are called ad hoc commands. Basically, you use Ansible, and I've already made an inventory file. Let me show you that. Inventory. This inventory file describes the 4 nodes in my cluster, and it tells it the IP address. It tells it the role for Kubernetes. That's a variable that I use in my Ansible code to say, like, this is the master, so the master stuff gets on it. These are the nodes, so the node stuff gets on them, and they connect to the master. So I tell Ansible about my Kubernetes cluster, all the different nodes, there are 4 of them there. And then I can say Ansible inventory, so you have to tell it about your servers. And then I say I want to operate on all the servers, and then I'm going to use the service module. Ansible is split up, so Ansible could run shell scripts on your servers. That's one way you can use it. And in the beginning, that's how a lot of people start using it, because they're familiar with shell scripts or individual shell commands that you can run. So that's a nice little way to optimize your infrastructure management. But it also has modules that do the things that you normally do in shell scripts. So for instance, there's a service module, and it controls services running on your servers. So in this case, I have a service that I've created for those little LEDs. Those LEDs are called Blink Stick Nanos, by the way, if you want to buy one. They have an RGB LED in them that you can control via Python libraries. It's pretty cool. So I made a service called Dramble Node Monitor, and I'm going to say I want that service stopped because I want to demonstrate something using those LEDs. And then I give it -b. -b means become, so become another user, and then if you don't give it another argument, it becomes the root user. So this service is running as a root user, so I need to tell it, do it as sudo turn this off, please. So I'm going to do that, and I gave it an extra option here. Inventory all service. Oh, I forgot -a, the arguments. There we go. And so that's going to go out to the Pis and say, hey, turn off the service on each one of you. First time it connects, it takes a couple seconds because it's making that initial connection. But if I do this again and say started, it should connect pretty quickly this time, like 1 or 2 seconds instead of 3 or 4. Although when it's using the service module, it's probably a little bit slower. So I'm going to turn those off, and then I'm going to use the Blink Stick library that's installed on the Pis. And I should have just retyped this. Anyways, Blink Stick blue, so I can turn the lights blue. And I just upgraded Ansible last night, so I'm getting lots of warnings because I'm using old defaults. I can turn them green. And you've just witnessed the second time that there's been a blue-green deployment in person at a Drupal camp. So, everybody says they're so hard, but that was very easy, blue and green. Let's see what people think is so hard about doing blue-green. So another thing that we can do is use Ansible to orchestrate. So earlier I showed you that inventory file that has like the master and the nodes and things. So Ansible can do a lot of powerful things, including local, remote, and cloud orchestration. So you can do something like bring up a service in Amazon, bring up some local servers, connect them to that service in Amazon, connect them to your local computer to do some API calls, things like that. It's all very powerful and flexible. And to demonstrate that, let me first make sure. I need to play an audio sample just to make sure that my computer is not turned way down. Okay, it is. It's not turned on, so that's good. So I'm going to run a playbook that I have. And this playbook will orchestrate the Ansible servers to do something special. Inventory, testing, presentation, Ansible encounters. And so what this is going to do is turn off the lights and then do something a little bit special. Let me show you the lights here. So you've had an Ansible encounter of the first kind, and the second kind, and the third kind now. So does anybody know what, actually since I said kind of the part of the title, does anybody know who was the director of that movie that is referenced through that song? Yeah?
Steven Spielberg.
Yes, Steven Spielberg, Close Encounters of the Third Kind. I had to watch it again after I did this presentation, so you can grab that. We're now one of 45 or so exclusive members of the Raspberry Pi Dramble sticker owners. So that's how Ansible can kind of manage these things. Ansible can also do things with Kubernetes on the different nodes. Because I don't have hours and hours to go through it, at the end, if we have a little time, I might be able to show a little bit more how Ansible is, in particular, controlling Kubernetes on these nodes. But I'm going to use Kube control is what I call it, but kubectl, you mentioned this yesterday. There's a whole debate. It's kind of like, the DrupalCon has changed faces over the years, but we still have that old, 2006 version That's the official DrupalCon. There's 1,000 ways to pronounce this thing, but there's a command line utility called kube control, and it's used to control your Kubernetes clusters. So I'm going to show all the different things that are running inside Kubernetes right now. Git pods, go ahead. So a little description of this namespaces. It's very particular. I ran the command kube control get pods. Kubernetes has dozens of built-in resources, and you can extend it with your own kind of resources. And with all these different resources, it has a very standardized API where you can get a list of things or the basic information. You can describe an individual object so you can see everything. You can edit it inline. You can use Ansible to edit it. You can use other tools to edit it. And Kubernetes has a few different things that are kind of like the basic building blocks of a cluster. And one of those is a pod. And a pod, now remember this is the training wheels presentation, you can think of a pod as a container in Docker. That's not exactly true because there's a lot of cases where a pod is not a container, but a pod is basically kind of like a container in Docker. And in this case, we have pods that are named kind of funny. So there's like Drupal 7b88 and all this stuff, and MySQL. These are named this way because Kubernetes is actually building and tearing down and managing these pods for me as part of a deployment. And a deployment kind of describes how you want your pods to be structured. And then Kubernetes, like I said, you tell it what you want it to do, and then it will do stuff. So like if I deleted this Drupal pod, and let me show you right now what it's serving up. If I go to cluster.pydramble.test, it's serving up the Raspberry Pi Dramble website. And I'm not connected to the internet, so this is all local. So it's serving this off that cluster. And if I delete this Drupal pod, right now there's only one Drupal pod running. Not very good for HA. But if I delete it, and I'm giving it a namespace of Drupal, in Kubernetes you can split up your different things by namespaces for isolation of resources and isolation of secrets and things like that. So I'm going to delete this Drupal pod, which is this one, and if I delete it, and I get my pods again, so I just deleted it, and now it's giving me service unavailable because I didn't have another pod running for it to load balance that to. It's going to, in the background, start being like, oh my gosh, this pod is gone, and he wants me to have a pod running, so I'm going to start running another one. Of course, it's very slow, but it looks like it already brought a new one up. And the command line, of course, is still probably cleaning up this other one. On the Raspberry Pi, this takes a little longer. If you're on a real server, deletions are a lot quicker. So there it is. And if I go back to get pods, all namespaces, so the first one was like 7b88, R77b5. Now it's a new one, 4zfxh. So it saw that the pod was deleted, and it's like, I want that new pod, so it brought one back up. Now, there's another thing that I'm going to do, and this could be a little bit dangerous because MySQL's running on there. This is one disadvantage of running a presentation with only 4 nodes, is you can't split things up super easy across all of them. But I'm actually going to shut down Cube 3, basically. And you can see that there's some things running on it. There's the NFS client that does the shared file system. There's MySQL running on there. There's some other things for networking and Kubernetes stuff. So I'm going to SSH into it. Let's see. And again, I can do this through Ansible, but I'm kind of just showing how this is done by hand because some people may be a little more familiar with this method. So what I'm going to do is I'm going to stop the process called kubelet. Kubelet is what Kubernetes uses on each individual server to make sure that everything is the way it should be. So I'm going to say sudo system control stop kubelet. And when I do this, let me go back here, you're going to notice that within a few seconds, this Dramble node monitor thing turns that LED red because it notices, hey, that Kubernetes node is gone. If I go over here and say watch kube control get nodes, so I'm getting all the nodes, the node status, and Kubernetes every 30 seconds or every 60 seconds does a check for node readiness, and what it basically does is checks in with that node's API endpoint, or the node checks in with Kubernetes API, and it says, hey, I'm here, hey, I'm here. So what happens is right now it's not doing that, and Kubernetes is like, what's going on? So it has a little bit of a timeout, a grace period, and as you can see, it just noticed that actual node is not ready anymore. So at this point, if I say watch kube control, get pods, all namespaces again, to see what's going on, I can see that MySQL is still said, it still thinks it's running on kube 3, but Kubernetes again is hitting that timeout and being like, something's wrong here. So we're going to wait just a minute and see what it does. It should, at some point here, pop that over. You can see now it's setting all the things that were on kube 3, it's setting to terminating status. Now, of course, since that node is down, it can't actually terminate them, but the API is going to keep track of it so that if it does come back up, it will terminate it. You can see that MySQL is now running on kube 4. So I moved that over, and let's see if the site is still working. Of course, there's an unexpected error. And this is where this particular, oops, how is it going here? This particular run of this presentation might be a little messed up because if MySQL is on the wrong node that I take down, MySQL is actually running on NFS, and that's a horrible idea. Don't ever do that. But I'm doing it because it was easy. And MySQL holds a lock when it's open, has an open database connection. And if you take down the server that was holding that lock without that lock cleanly closing, the new server that comes up is not going to come back happily. So what I'm going to do is I'm going to say start kubelet again on here. All right. And it should show that, yeah, so that turned green again, the light on there. If I go back here and say, watch the nodes, it already says that kube 3 is healthy again. And if I go back here, it looks like it already terminated the one on kube 3. So let me see. Let's see. So it finally came back up because kube 3 came back up. The container closed out its lock for MySQL, and then kube 4. So let that be a lesson. Don't run MySQL on NFS. And also don't run MySQL in a very non-HA way like I'm doing here. At some point in the future, I'm hoping to get MySQL to be running with an HA setup where it uses the local disks on the Pis. But that gets really complicated because NFS is bad, but also micro SD cards are bad. There's really no good storage option on a Raspberry Pi. And again, this is why you should probably not be running production infrastructure on a Raspberry Pi. But I do, and I don't recommend it though. All right, so another thing that's cool about Kubernetes is the fact that it takes a lot of things, like a lot of features of Amazon and Azure and Google Cloud and things. They're very proprietary. Like Amazon has a really cool thing with elastic load balancers and what is it called, autoscaling, whatever the autoscaling setup is that they have, where you can say, like, when my servers start getting hammered with lots of requests, or when CPU goes up, I want you to add more servers so that I can handle the load. And then when I'm finished, delete those servers again. That's a pretty cool thing to be able to do, because then instead of you getting lots of traffic, like let's say a news article on your news site gets hammered, or you do a press release, and all of a sudden it gets linked to from some giant website like Reddit's homepage or something, your site can stay up even if there's lots and lots of traffic. There's other ways to combat that, like for a lot of Drupal sites, if you have Varnish, that'll take care of a lot. But sometimes you do need to scale up and scale down. And Kubernetes has this as a core thing that's kind of built into it. It has something called an HPA, or horizontal pod autoscaler. So for anything that you run, you can tell Kubernetes a certain set of conditions, like if the CPU gets this high, or if there are this many web requests, or if the memory is getting this high, go ahead and scale up and give me more of these. And Drupal, a lot of times, will run out of memory and or CPU, depending on what kind of things you're running. Like if you have a lot of authenticated traffic, CPU is probably going to be one of your big limits, and you want to be able to scale up and scale down. So I'm going to, I already have an HPA rule set up for Drupal that says when the CPU reaches, I think, 70% or 80%, scale up to have more Drupals available. And if I say watch, kube control, get HPA and Drupal. And it's going to show me that right now there's not a lot of load. Like when I'm going around here clicking on the site, it's not a whole lot that I'm doing. I'm just kind of clicking around, and it doesn't even have to render. It's serving from cache on a lot of these. So if I go to other pages, now it has to load the page, and you notice it's a little bit slower. If I did this for a while, the CPU would probably go up to like 2% or 8% or something like that, but that's not a whole lot of load. So I want to generate some more load on here. And another opportunity for one of these stickers, often you use A/B, so there's two questions here. Often you use A/B for load testing, for very informal quick load testing on a server, or just to hammer a server with a lot of requests. Does anybody know what A/B stands for? Yeah?
Apache Benchmark?
Yes, Apache Bench. So here's your sticker if you want to get it. And then there's another tool that I like to use because it's a little bit simpler in the command line, and it's called WRK. And does anyone know what that stands for? This is probably a lot more difficult because A, nobody knows what WRK is, and B, it's a very weird acronym. Okay, I don't either, so that's good. But anybody who wants, I have a few more stickers. At the end, you can come up and get them. That's all the questions I have, sorry. I can't think of any other ones. I've been through this presentation like 4 times, and I was like, what can I ask that I can give out more stickers? So anyway, we have this thing running, and I'm going to hammer it with some requests from this tool called WRK. Actually, yeah, it doesn't even say what it is. So I don't know what WRK stands for, but it's a cool thing. Maybe it's like wrap your server or something.
I always thought it was short for work.
Maybe work.
I literally thought that's what.
It could be, yeah. Like generate work or work on a connection or something. Anyway, it's a little easier to use than Apache Bench, although it doesn't have quite as many options. But it's good for this kind of quick test where I just want to get a lot of requests out. So I'm going to use 5 connections, and I'm going to do this for 2 minutes, so 120 seconds, and 5 threads. So I'm going to hit this site, cluster.pydramble.test, and I'm going to start hitting that. And you should see that this cube control, get HPA, this should start going up, the percentage of CPU usage. And if I look on the individual nodes themselves and showed you the CPU, you'd see that they're starting to ramp up quite a bit too, or at least the node that Drupal's on. And you can see right now, the baseline is 1 replica, so there's 1 Drupal instance running, and the minimum that I have set is 1 replica, so that's why there's only 1 running. And because Raspberry Pis do not have unlimited resources, I also set a maximum of scaling to 3. So there's always going to be a limit, unless you're running with unlimited funding, you always want to have an upper limit to what you want to scale to, because if you do get some massive amount of traffic, you don't have a bill of zillions of dollars from Amazon, which can happen if you don't have those limits in place. So this should pretty soon here get a little bit more. And there you go. So now it's showing that there's 268% of the CPU usage on that one poor little pod. And this replica's number should go up pretty soon as Kubernetes brings up more Drupal pods. And now it has 3. So at this point, oops, I don't know, open transmit. At this point, it should be serving more requests per second, should be able to perform a little better. It's still going to be hammered because this thing's basically saying, give me as much as you can, as fast as you can. But once that load wears off, it has a back-off time. I think it's by default 5 minutes. So after 5 minutes, it'll scale back down to 1 over time. So it'll cut off 1 pod, and then it'll cut off another pod, and it'll be like, okay, we're all good now. So if I also say get all the pods, you can see that it has 3 Drupals. Kubernetes also has a lot of controls for how you want to spread out your pods. So it would be really bad because these Pis are network constrained, they're memory constrained, they're CPU constrained. Everything's bad about an individual Pi. So if I put all 3 of those Drupals on one Raspberry Pi, it would be a very bad situation. So Kubernetes, by default, wants to spread them out. So have one on one, one on another, one on another. And you can even say, like, I have these high CPU nodes, I have these high memory nodes, I have these high network nodes. You can say, like, I want Drupal to be on the high CPU, and I want memcache to be on the high memory, or that kind of thing. And then Drupal, again, just does what you tell it to do. So you can see those are running, and that's about it for the live demo portion of this. Let me get back in here. Play. So how does it work in the real world? This new version of the cluster uses the Pi Power over Ethernet hat. HAT is I forget, hardware accessory top or something like that. I forget what the acronym's for. It's a little thing that sits on top of the Pi, and it has a built-in fan. And the Pis get really hot when you do things like hit them with lots of web requests. So these little fans turn on, and the smaller a fan is, the louder it is typically. And so these little fans are very loud. So I have not been running this exact Pi on my desk like I have the other versions of the Pi in the past as often. But I have been running it for a couple months, and I've been running another version of the cluster on my desk for months. And since 2014, I've had about 99.8% uptime, which is pretty good. Most of that downtime is because my ISP in St. Louis is terrible. What do you guys have here? I have Spectrum.
Fiber.
Do you guys have? Oh, well, you guys have Google Fiber. So Spectrum is 10 megabits uplink, and that's like as much. That's as much as I can pay for. Like I cannot get faster internet. So I'm wondering if when Starlink internet in 5, 10, whatever years gets up, if that'll be faster. We have no fiber in the suburbs in St. Louis, unfortunately. Anyway, most of the downtime's been because of that. But the cluster performs okay. A funny thing about this is the old version of this cluster that didn't use Kubernetes actually runs faster on my Mac than on the Raspberry Pi cluster. The version that uses Kubernetes runs faster on the Pi cluster than it does on my Mac. And a lot of that is because the way that Kubernetes distributes the CPU resources and the memory and things like that, it has a lot more isolation. Whereas with the old version of the cluster that I had, there were a lot more shared resources. So my Mac has 4 CPU cores. The Raspberry Pis have 4 times 4, so 16 CPU cores to split all that workload up. And Kubernetes actually does a really good job of splitting things up between the CPU cores. But in the old way, with the traditional VM, it kind of splits things up on an individual Intel I-series processor pretty well, even if you don't have as many cores. So that's just something interesting to keep in mind as we move into this new ecosystem. If you do start using Kubernetes for something, or something like Amazon ECS, or whatever containerized environment, the infrastructure type and the CPU cores and things like that matter a lot in how it performs. So something to keep in mind. And the lesson that I always learned from this is always do benchmarks and have a repeatable benchmark. Because otherwise I would have just presumed that my Mac would still be faster than the cluster running Drupal. But under Kubernetes, that's not the case. So some other things I've learned when I run a data center at my home, basically. If you go to pidramble.com, that's actually served on a Pi sitting on my desk at home. But as you can see, I'm not at home, so please try not hacking it, because if you do, then you get into my home network and I'm not there to defend myself. But there's some important considerations for thinking about running a Pi at home connected to the internet and exposed. You have to think about power, so I have a UPS, but it's like, I might get an hour or 2 out of it. So you probably wouldn't run any Fortune 500 stuff on a Pi at home, or any computer, really. My network, like I said, I have Spectrum, and that's as fast and as good as I can get, and it's not that great. Physical security, most data centers have 5 or 6 biometric security gates. My house has a lock on the front door, and you could probably use a sledgehammer to get through the door pretty quickly, so I wouldn't host anything super secure there. You also have to maintain a Pi, so you have to do updates to it, you have to upgrade the operating system here and there. The memory card might die on you, especially if you get a cheaper one. The power supply might die, all those kind of things. And what happens if you get a lot of traffic? On my Pi, I actually am running it behind Cloudflare just because I do have so many flaky outage moments with my ISP. But it's probably not a great idea to run production websites at home. I've considered moving my personal site to it, kind of just as a badge of honor for fun. But I've also considered that my personal website actually does have some relevant articles that help people and things like that, so haven't done it. And considerations for Kubernetes is a lot of people think that Kubernetes is like this magic bullet that's going to solve automation problems for them and solve all the hard problems of running things in the cloud and all that. And it solves some problems, but in my opinion, it actually requires more rigorous deployment automation. It requires more rigorous CI and CD practices. So if you're not already into all that stuff, you might not want to adopt Kubernetes immediately super fast right away, because you're going to need to do all these other things, like how do you build containers for Drupal, and how do you manage the container pipeline and the build pipeline. Do you use GitLab? Do you use some other tool? Where do you store all the container images? Again, the talk yesterday had some good ideas for that, using and some good diagrams with what tools they use at 10.7. And every organization is currently kind of figuring these things out on the fly, because you need a place to put your code, and you need a place to put your images, and you need a way to securely transfer things between them. You also don't want to pay tons of money for network bandwidth with certain providers like AWS. Another thing that can be tricky with Kubernetes is something called RBAC. Actually, here's another question. What does RBAC stand for? Anybody? You already got a sticker, but...
Two of us, yeah.
Okay.
Role-based access control.
There you go.
Because I Googled it while you put the slides.
Yes. So role-based access control is an extremely powerful part of Kubernetes, but as they say, with great power comes great responsibility. There have already been 2 times that I've personally witnessed somebody adding a role to a cluster that granted everything in the entire cluster complete, full admin access, to the point where I've added a pod to every cluster that I build, not this one, but every production cluster I build. The pod literally tries to create and delete other resources, and if anything is allowed, it will send me an email and say, this cluster is compromised. And it's not like compromised like a hacker, it's compromised because you copied and pasted some code from somewhere, because something like RBAC is sometimes hard to get right, but it's really easy to get wrong. And that's a problem, because a lot of times when you're starting out, you're like, man, I want to get this right, and this thing looks like I copied and pasted it, and now I can do my build process. But in the process of doing that, you also granted full cluster access to everything in the cluster. There's also monitoring tools for Kubernetes out there that I've seen that give full cluster access. That's not a good thing. And this was something that was mentioned yesterday in Tessa's presentation as well. Stateful things like storage is still not easy. It's just as challenging in many ways with Kubernetes. Some parts of it are easier, like attaching that storage to multiple things. But the actual storage itself, you're going to have to figure out what the best storage for your needs are. So whether it's NFS or GlusterFS or Ceph or S3, different types of things like that. You're going to need a dictionary for the first 6 months at least, probably the first year, just to remember what the difference is between stateful sets, replica sets, deployments, pods, and all these different terms that I've gone through. And to sum up with Kubernetes, if you do it well, you can do really amazing things. And I am very optimistic about Kubernetes and starting to use it a lot more. We're using it for a lot of production stuff at Acquia already, and lots of companies have adopted it very quickly. It's definitely like the next big thing in infrastructure, because like a data center in a box, basically. It has all the cool tools. However, if you don't do it the right way, if you don't take the time to get it right, you're going to have what I call failure at web scale, where you accidentally give access to everything everywhere, or you have some settings set up that are not good defaults, and then everything gets owned at the same time. So, in the end, how well does Drupal 8 actually run on these Pis with Kubernetes? It runs well enough that I've kept using it since I started the process of converting the cluster over to Kubernetes in 2017. Initially, I had worries that it would be really hard, but one cool thing about the Kubernetes community is I forget the guy's name, there's like a teenager who wanted to make sure that Kubernetes ran on ARM computers. ARM is the processor type in a Raspberry Pi. It's different than the Intel chips and the AMD chips in our laptops. And so he spent a lot of time and worked with some other people in the Kubernetes community to make sure that ARM builds are always like tested and well built and work on Raspberry Pis and things. So it's actually a lot easier than I originally thought to keep Kubernetes updated. Like, I haven't had a problem with any Kubernetes version since 1.11 or 1.10 or something like that, when there was a little bug that was not caught. So it runs okay. Again, I would not recommend it for your own personal use for any important things, but I would recommend playing around with it and seeing what you can do. A cool thing is, in the first link, the Raspberry Pi Dramble, or pidramble.com, it has a link to all the source for this presentation, which includes, if you don't have Raspberry Pis, like I have 4 of them, if you just have one, or if you have just a computer, you can actually run the entire thing locally in a virtual machine, or in a series of virtual machines, and you can still get experience with the same setup that I have. There's other ways to run Kubernetes locally, of course, lots of different ways, and there's lots of other ways to get an introduction to Kubernetes, but if you want to bootstrap something that automatically starts up Drupal and starts running it out of the box, this is a cool little project. There's also some other resources out there. I have the website, pidramble.com, which is a Drupal 8 website. It's set up for Kubernetes specifically, so some of the changes and things are in that code base, and you can see how the code base was built. I have a README and tutorial for like how to build your own Kubernetes-sized Drupal code base. I also wrote a book on Ansible for DevOps. Unfortunately, I don't have any copies with me because I'm too lazy to remember to order author copies to bring with me to places. I even drove, so I could have brought a box of them, but sorry. But I do have, I always forget to mention this, I do have little business cards up here with a 25% discount. Instead of $9.99, it's $7.49 if you want that. And on my blog, I blog about a lot of the things that I've learned through this process. So thank you.